Hi friends, welcome to all. In this video we are going to see the packet tracer activity, designing and implementing a VLSM addressing scheme. Here is our objective of this packet tracer. In part 1 we will examine the network requirements. In part 2 design the VLSM addressing scheme. And in part 3 we will assign IP addresses to devices and to verify connectivity. We will go through the background. In this activity we are given a /24 network address to use to design a VLSM addressing scheme. So based on a set of requirements, we will assign subnets and addressing, configure devices and to verify connectivity. We will come to part 1, examine the network requirements, determine the number of subnets needed. So you will subnet the network address at 10.11.48.0/24. The network has the following requirements. Here we can see that the LAN ASW1 will require 14 host IP addresses. For ASW2 LAN will require 30 host IP addresses. ASW3 LAN will require 6 host IP addresses. And ASW4 LAN will require 60 host IP addresses. So how many subnets are needed in the network topology? Right, we will see that. Come into the spreadsheet. Here we can see our subnet table. So here we given the subnet description and the number of hosts needed in a descending order. Here we can see for the ASW4 we needed 60. This is the maximum number of hosts needed. And here we can see ASW2 30, ASW1 14 and ASW3 6. And also we required a WAN link. We required 2 number of hosts. Now we will see the network address, first usable host address, last usable host address and broadcast address of each subnet according to the number of hosts needed. We will come to step 2. Determine the subnet mask information for each subnet. Which subnet mask will accommodate the number of IP addresses required for ASW-1 and how many usable host addresses will this subnet support? Right, we will come to our spreadsheet here. Yes, so for the ASW1, the sub description, we need a total number of 14 hosts in this subnet. Here we can see the details. So the network address is 10.11.48.96/28. Here we can see the first usable host address is 10.11.48.97 and the last usable host address is 10.11.48.110. and here we can see the broadcast address 10.11.48.111. So the number of usable IP addresses here are 14. Now we will come to B. Which subnet mask will accommodate the number of IP addresses required for ASW-2? How many usable host addresses will this subnet support? Right, we will come to our spreadsheet here, and here we can see for the ASW-2 we need the number of hosts needed is 30. So here the network address is 10.11.48.64/27. Here we can see that the CIDR/27. That means the subnet mask will be 255.255.255.224. and here we can see the first usable host address 10.11.48.65. and here is the last usable host address 10.11.48.94. and here is the broadcast address 10.11.48.95. and here mentioned the number of usable IP addresses are 30. Now we will come to C. Which subnet mask will accommodate the number of IP addresses required for ASW-3? How many usable host addresses will this subnet support? Right, coming to our spreadsheet, here we can see that ASW3. Okay, here the number of hosts needed is 6, and here the network address is 10.11.48.112, and here the first usable host address is 10.11.48.113, and here the last usable host address is 10.11.48.118, and here the broadcast address is 10.11.48.119. Also the number of usable IP address are 6. Now we will come to D, which is subnet mask will accommodate the number of IP addresses required for ASW-4, and how many usable host addresses will this subnet support. Right. Here is our spreadsheet, and here we can see the subnet description ASW-4, and here we required a number of host is 60, and here the network address is 10.11.48.0/26. so here we can see the CIDR is /26. so the subnet mask will be 255.255.255.192, and here we can see the first usable host address 10.11.48.1, and the last usable host address is 10.11.48.62. here we can see the broadcast address 10.11.48.63, and the number of usable IP addresses are 62. Coming to E, which subnet mask will accommodate the number of IP addresses required for the connection between building 1 and building 2. Coming to the topology, here we can see building 1 and building 2 serial connection. So here in our spreadsheet, here we can see the WAN link, the number of hosts needed is 2. Network address, here we can see with the CIDR 10.11.48.120/30. That means the subnet mask will be 255.255.255.252. Also here we can see the first usable host address 10.11.48.121, and the last usable host address is 10.11.48.122. here the broadcast address is 10.11.48.123. here the number of usable IP addresses are 2. Now we will come to part 2, design the VLSM addressing scheme. Step 1, divide the 10.11.48.0/24 network based on the number of hosts per subnet. Yes, we have seen that already, we have done that. Use the first subnet to accommodate the largest LAN. Use the second subnet to accommodate to second largest LAN. Use the third subnet to accommodate the third largest LAN. Use the fourth subnet to accommodate the fourth largest LAN. Use the fifth subnet to accommodate the connection between building 1 and building 2. Yes, this is what we have seen in our spreadsheet. So here we can see we given the largest subnet here 60. So in that order, in descending order, we noted that. Then we got all the network address for these subnets. Next is step 2, document the VLSM subnets. Complete the subnet table listing the subnet descriptions. Here we can see that how we have to do that. Then number of hosts needed, the network address for the subnet, the first usable host address, the broadcast address. Repeat until all addresses are listed. So here is the subnet table, and we have done here in our spreadsheet. Now we will come to step 3, document the addressing scheme. Assign the first usable IP addresses to building 1 for the 2 LAN links and the WAN link. Assign the first usable IP addresses to building 2 for the 2 LANs link. Assign the last usable IP address for the WAN link. Then assign the second usable IP addresses to the switches. Assign the last usable IP addresses to the host. Yes, so we will document these addressing schemes. Here we can see our addressing table according to the addressing scheme mentioned in our packet tracer activity. The device interface and its IP address here we can see. Then the subnet mask, also we can see the default gateway. Now we will come to part 3, assign IP addresses to devices and to verify connectivity. Most of the IP addressing is already configured on this network. Implement the following steps to complete the addressing configuration. So here we are going to configure IP addressing on building 1 LAN interfaces, then configure IP addressing on ASW3 including the default gateway, configure IP addressing on host D including the default gateway. Then finally we have to verify the connectivity. You can only verify connectivity from building 1, ASW3 and host D. However, you should be able to ping every IP address listed in the addressing table. right? We will assign these IP addresses into the respective devices. Coming to building 1 CLI, right? Enable configure terminal, and we will go to the interface gigabit Ethernet 0/0, and we will set the IP address 10.11.48.97, and here is a subnet mask 255.255.255.240, right? Now we will get the no-shut command. Yes. Now we will do it on the other interface, LAN interface. So we have to go to the interface gigabit Ethernet 0/1, and we are going to set the IP address 10.11.48.65, and here the subnet mask is 255.255.255.224. Now we will give the no-shut command. Now we will configure IP addressing on ASW3. Here we can see that ASW3 is switch. So coming to CLI, enable configure terminal, we will go to the interface VLAN 1. Now we are going to set the IP address 10.11.48.114, and now we have to set the subnet mask 255.255.255.248. Now we have to set the default gateway, so we have to exit here. IP default gateway we have to give, that is a 10.11.48.113, right? I think we did not give the no-shut command here in this interface, so we will give that. We will go to the interface VLAN 1, and we will give no-shut command. Yes. Now we will configure this host D. So coming to host D, desktop, command prompt, we have to go to IP configuration. So here is the IP address, that is 10.11.48.62, right? Here we can subnet to mask. We have to change this default subnet to mask to 255.255.255.192, and now we have to give the default gateway. I'm going to copy this address. It's a 48.1. Yes. Now we are going to verify the connectivity. We will ping from this host D to this host A. So we have to get the IP address of host A. Here we can see that, right? Coming to host D, command prompt, here I am going to give ping, then the IP address. Wait for that. Yes, we are getting the reply. Now we will ping from host D to the switch ASW3. So coming to command prompt, here we are going to give ping and the IP address of that switch. Waiting for the reply. Request timed out. Yes, we are getting the reply. So once more, if we give, you will get 100% success, right? Yes, that's all in this packet tracer activity. Here we can see the completion status 30 out of 30. So in this we have seen designing and implementing aVSLM. Friends, if you have any doubt in this packet tracer activity, please comment below. Also, if you like my video, give a thumb, and don't forget to subscribe the channel so that you will get latest uploading video info into your Gmail. Thank you.